I come on number system, there are two types, positional number system and one more is non-positional number system. In the base 8 if I am going to write, then it cannot be called as octal number because the digits here we are written 28, then 8 is not in the list. Hexadecimal number system consists totally 16 digits, starts from 0 to 9 and A to F. The leftmost bit always called as most significant bit and the rightmost bit is always called as least significant bit. Welcome to one and all. Myself Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we will start with the first session of Data Representation chapter. On this chapter, in the annual exam, you will get 8 marks. Only 2 questions they will ask in the annual exam. In part C, 1 question for 3 marks, as well as in part D, 1 question for 5 marks. The total weightage of this chapter is 8 marks in the annual exam. Whereas on this chapter, you will study regarding different types of number system, that is positional number system, what do you mean by non-positional number system, how to convert from one radix to other radix format like decimal, octal, hexadecimal as well as binary. Then what do you mean by computer codes, how here it will work, the advantage of that, as well as 1's complement and 2's complement. Regarding that, you will study on this chapter. Whereas on today's session, you will come to know introduction regarding data representation. Then, what do you mean by non-positional number system? Then, positional number system. Under positional number system, what do you mean by decimal number system, binary number system, octal number system, as well as hexadecimal number system. Regarding that, you will come to know on today's session. First, we will discuss about what do you mean by computer, then which type of language computer can able to understand, why we need binary, the advantage of binary. Regarding that, first we will explain. Whereas computers can able to understand only the binary languages, that is zeros and ones format, that is low level language, binary level language or machine understandable language. Whereas in digital computer, data and instructions are stored in the computer memory using binary code. That means all the instructions will store in the format of zeros and ones only, represented by binary digits 0 and 1. That is in binary format, in bit format, the computer can able to understand, store the data. Whereas the number system uses well-defined symbols, call it as digits. It uses the symbols to represent that symbols can be called as digits here. The number systems are basically classified into 2 types. One is non-positional number system and one more is positional number system. When they come on number system, there are 2 types, positional number system and one more is non-positional number system. Then what do you mean by this non-positional number system? Whereas in this non-positional number system, it will depends on exactly which position we are written, that doesn't matter here. For example, if I am going to write Roman number 1, then one more 1 I will write. Then here it is 2. If I am going to interchange their position, first I will write the second one and then I will write the first one. Then also it will not affect non-positional number system. If I change the position, then also it will not affect, that is nothing but non-positional number system. But when they come on positional number system, for example, I am going to write 1 and then 0. Then if I am going to interchange the position for 0 and then 1, then their value will changes here. That is nothing but positional number system. Non-positional means it does not depend on the position, whereas positional number systems, the name itself suggesting that positional. That means it mainly depends on the position, on which position the element, the digit is present. Depending upon that also, the value will changes. When they come on non-positional number system, the non-positional number system consists of different symbols that are used to represent the numbers. Especially here, it uses the numbers, that numbers are Roman numbers. Roman number system is an example for non-positional number system. For example, for 1, we'll write like this. For 5, we'll write V. For 10, X. L represents 50, like that. If I'm going to interchange the position, then also it will not change. That's why it is called as non-positional number system. This number system cannot be used effectively to perform arithmetic operations. This is not effectively used because all digits, all symbols here will not work properly here. But when we come on positional number system, already I told you it depends on the position. For example, if I am going to write 8 and then 3, then it is 83. If I am going to reverse their position, first I will write 3 and then 8, then the value will changes here. That's why it is called as positional number system. Exactly that digit on which position it is present. Depending upon that also we are going to identify here. In this type of number system, there are 4 types: decimal number system, binary number system, octal number system, as well as hexadecimal number system. When we come on positional, there are 4 types: decimal, binary, octal, as well as hexadecimal number system. Whereas the decimal number system consists of digits from 0 to 9. It consists, the total digits starts from 0 to 9 in decimal number system. Decimal means 10. But at the last, we are not written 10, but it starts from 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Then decimal number digits contains totally 10 digits starts from 0 to 9. And with that, in the radix, we used to write 10. It means that the radix represents the total number of digits present in that number system. Whereas here, the total digits represents 10 here. Radix or base represents the total number of digits. Whereas in decimal number system, the total number of digits present are 10. Radix represents total number of digits present in that number system. Then the next one is binary number system. This binary number system consists the digits 0 and 1 only. Only 2 digits it contains, that is 0 and 1. And here the radix contains only 2. Why here it is 2? Because it contains only 2 digits, that is 0 and 1 only. That's why here the radix represents 2. And the next one, octal number system. Octal means totally 8 digits it contains, but it starts from 0 to 7 only. 0 to 7 only. It contains the digits, starts from the digits 0 to 7. That is 0, 1, 2, 3, 4, 5, 6 and then 7 only. And here in the radix we used to write 8. In the base we used to write 8. That means in this octal number system, it contains totally 8 digits, starts from 0 to 7 only. And the next one is hexadecimal number system. Whereas in hexadecimal number system, on that case, the radix represents 16. In the base, we used to write 16 here. It means that totally it contains 16 digits. Which are the digits? It starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Afterwards, on the place of 10, we will represent A, B, C, D, E, F. Totally it contains 16 digits start from 0 to F. That is from 0 to 9 and A to F. Whereas what exactly the A represents? A represents 10, then 11, 12, 13, 14 and then 15. Total digits here we have 16 digits. On the place of 10 we used to write A. On the place of 11 we used to write B. On the place of 12 we will write C. On the place of 13 we will write D. On the place of 14 we will write E. And on the place of 15 we used to write F. That means here in hexadecimal number system it contains totally 16 digits start from 0 to 9 and then A to F. Whereas in decimal 0 to 9, whereas in binary 0 and 1 only, whereas in octal 0 to 7, whereas in hexadecimal 0 to 9 and with that A to F. Now, one by one we'll discuss. The total number of digits present in any number system is called its radix or base. What do you mean by radix? Already I told you. Whereas if you observe here, I told you in decimal number, the radix is 10. Whereas in binary, 2. In octal, it is 8. In hexadecimal, it is 16, I told you. It means that how many digits here it contains. Whereas in decimal number digits, it contains the total number of digits are 0 to 9. That is total 10 digits it contains. Here, the total number of digits present in any number system is called as radix. Because usually you will going to get the question, what is radix for 1 mark. Then every number system is represented by base. Which type of number system? Base, which represent x digits. Whereas how many digits exactly it contains, that can be called as radix. The base is written after the number as subscript, such as 360 here we are given, on the base we are written 10. That means it is a decimal number digits. It is a decimal number digits and base contains 10. For example, if I am going to write 430, in the base 10 I am going to write. Then from that I can identify 430 is a decimal number system. For example, 273, in the base if I am going to write, then it is an octal number system. For example, if I am going to write 273, then which type of number system it is? Because in this I not mentioned which type of number system. Only I written 273. Then it is a, in default, if we have not mentioned any radix, then on default it will take it as decimal number system. ಹಾಗಂದ್ರೆ ನಾವು ಬೇಸಲ್ಲಿ ಯಾವುದು ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ ಅಂದರೆ then default it will take it as decimal only. Then here 273 it is considered as a decimal number if you not mentioned any radix. Now is it clear? Next, to determine the quantity that the number represents, the number is multiplied by an integer power of x depending on the position it is located, and then find the sum of weighted digits. Then for example, consider a decimal number 512.45. It is a decimal number because in the base we are written 10. Then which can be represented in equivalent values are, see, first I will take 5, 1, 2, 4, then we have the values. If you observe here, see here 5, then 1, 2.45 we have. Here we have the point, decimal point. Here see, for 2, here we will write 2 first we will write, then here into 10 to the power of 0. Then here plus, next digit 1 into 10 to the power of 1 plus 5 into 10 to the power of 2. Here 0, 1 to the powers are increasing from right side to left side. After point, see here, after point we have 4 into 10 to the power of minus 1 plus 5 into 10 to the power of minus 2. If you observe this, here what happens? Here the power 10 to the power of 0, 10 to the power of 1, 10 to the power of 2. For 5, minus 1, then minus 2 we will write. Now is it clear? That means if you have point from right side to left side, the value increases. After point from right side to left side, here the values are increasing, but in with negative sign. Next, decimal number system. It is the most widely used number system. Already I told you. With that, the decimal number system consists of 10 digits from 0 to 9. Already in this chart I told you, decimal number digits contains totally 10 digits start from 0 to 9. Then here it has 10 digits and hence its base or radix is 10 here. These digits can be used to represent any numeric value. Example, 140 in the base 10 we are written, that is a decimal number. 555 on the base 10 we are written, that is a decimal number. 3200 we are written in the base 10, from that also I can identify it is a decimal number system. Next, if you observe, consider a decimal number system which can be represented in equivalent values are, see here 5, 4, 2, 0.72 we have. First here I will write 5. See, weight is 10 to the power of 2. Then for 4, 10 to the power of 1. For 2, 10 to the power of 0. Point. For 7, 10 to the power of minus 1. For 6, 10 to the power of minus 2. If you observe here, 5 into 10 to the power of 2, that is 500. 10 to the power of 1 is 10 into 4, 40. 10 to the power of 0. If any number, if the power is 0, then their value is 1 only. For example, 10 to the power of 0 is also 1. 100 to the power of 0 is also 1. 8 to the power 0 is also 1. The number may be any number. If the power is 0, then the value is 1 only. Then 10 to the power of 0 is value is 1. Then 1 into 2 is 2 here. Then if you observe here, 7, 10 to the power of minus 1. Then how you can write? That is 7 divided by 10. Then the value is 0.7 here. In the same way here we have 10 to the power of minus 2, 6. Then the value is 0.06. How to represent? 6 divided by 10 to the power of 2 here we have to write. If you want to make positive, see, write down denominator, then automatically the value you are going to get. Here 10 to the power of minus 2, to make it as positive, 10 to the power of plus 2. Division pattern we have written. Binary number system. Digital computer represent all kind of data and information in the binary system only. In the binary format only, the computer can able to understand. Binary number system consists of the digits only 0 and 1 only. If you observe here, already I told you, in binary it consists the digits 0 and 1 only. Then here, its base is always, the radix is 2. It contains the base value is 2 only. Each digits or a bit in binary number system can be represented as 0 or 1. In the format of 0 as well as 1, it's a combination of 0 and 1 only. With that, in the base, in the radix, we used to write 2. Here, the positional values are represented in power of 2 format. Here, for example, 1, 0, 1, in the base 2, we are written 111 on the base 2. Then 1, 0, 0, 0, 0, 1 in the base 2, we are written. It means that all these are combination of zeros and 1 only. With that, in the base, we are written 2. From that, I can identify it's a binary number. For example, if I am going to write 101, then which type of number it is? Here in the base, if you not mention anything, then default it is decimal number. In the base, if I am going to write 2, then it is a binary number. The digits consist from 0 and 1 only, and with that the base value is 2 here. And the next one, here consider a binary number system 11011.10, which can be represented equivalent values as here. You just observe here 11011. Take the values here 1 1 here from this side, from point from right side to left side 11011. Here for this one 2 to the power of, always you have to increase it by 2 to the power here. When it is binary, then 2 to the power you have to take. If it is decimal, 10 to the power you have to represent. Then 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. Here, after point, if you observe here, 11011.10 we have. That's why here 1 into 2 to the power of minus 1, 0 into 2 to the power of minus 2. Here it is 0, 1, 2, 3, 4. After point minus 1, minus 2 we have to represent. Then this value is 1 into 2 to the power of 4, that is 16. 1 into 2 to the power of 3 is 8. 0 into 2 to the power of value, if I am going to consider, then their value always it represents 0 only. Here 0 into any number, then we are going to get 0. Because here 4. But here if I am going to consider, then the values here, for this one it is 4, and when I do the calculation, then the final result will be 0. But now the power, the value is 4 here. Then here the 2, and then here 1, then 0.5, that is 0.25. In binary number system, the leftmost bit 1, the leftmost bit always called it as most significant bit, and the rightmost bit is always called it as least significant bit. Next, we'll move on to the next one, octal number system. Then what do you mean by this octal number system? The octal number system has the digits starts from 0 to 7 only. It contains the digits 0 to 7, but total digits are 8, but start from 0 to 7. The base or radix of this number is always 8 only. Already I told you, it contains from 0 to 7. In the base, we used to write it as 8. The positional values are equivalent in power of 8 format. If it is octal number, then it has to be multiplied with the power 8 of. Then, any digits in this number system is always less than 8 only. For example, if I am going to write 27 in the base 8, that is an octal number. For example, 28 in the base 8 if I am going to write, then it cannot be called as octal number because the digits here we are written 28. Then 8 is not in the list. That's why it is not at all an octal number. For example, 222 in the base 8 is an octal number. 450 is an octal number. 700 is also octal number. The digits start from 0 to 7 only. It's a combination of 0 to 7 only. The number system 6418 is not an octal number because here we have the digit 8. If you contain 8, that it cannot be an octal number. Now is it clear? Next, when we come on the weightage as well as values, on that case, consider the values here 234.56. Then here, see here the power 4 to the power here 0, 1, 2 we have to consider. For 5, minus 1, minus 2. The values 2, 3, 4, then 0.56. For 4, we are written 8 to the power of 0. For 3, 8 to the power of 1. For 2, 8 to the power of 2. Then, for the value 5, 8 to the power of minus 1. For the value 6, 8 to the power of minus 2. Then here 18 square, that is 64. Then 8 power 1, 8. 8 to the power of 0 is 1. Already I told you, that is, if any number, if the power is 0, then the value represents 1 only. If it is 100 to the power of 0, then also it is value 1. If 8 to the power of 0, then also it is value is 1. If 16 to the power of 0 is value is also 1 only. Then 8 to the power of minus 1, then 8 to the power of minus 2, that 0.015625 is the value on this case. Next, when we come on hexadecimal number system consists totally 16 digits, starts from 0 to 9 and A to F. The letters A to F represents the decimal numbers from 10 to 15. See, hexadecimal digits contains totally 16 digits, 0 to 9 and A to F. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15. Whereas here, the letter A represents 10, B represents 11, C represents 12, D represents 13, E represents 14 and F represents 15. The base or radix of this number system is always 16 only. It's a combination of 0 to 9 and A to F. For example, A3, it is an hexadecimal number because A is also there in the list, 3 is also there in the list, and with that in the base is 16. 2BC, then it is an hexadecimal number. Face, it is also an hexadecimal number. E, if I am going to write, then also it is an hexadecimal number. For example, if I am going to write only 123, then here it is a decimal number because in the base we have not written any values. In the base, if I am going to write 8, that is a octal number. For example, in the base, if I am going to write 16, that is an hexadecimal number. Now, in the same way, consider one hexadecimal number 5AF.D. It is a hexadecimal number. It can be represented in equivalent value. See, here for F, 16 to the power of 0 we have to consider because it is an hexadecimal number. Here 16 to the power 1, 16 to the power 2. Whereas here 16 to the power minus 1 we have to consider. See the values for F 16 to the power of 0, for A 16 to the power of 1, for 5 16 to the power of 2. After point 16 to the power of minus 1, then their equivalent value 256, 16, 1, 0.0625. 16 to the power 0 always 1 only. Now is it clear? If I consider the numbers, already I told you, binary, octal, decimal, hexadecimal. In binary, the base, the radix is 2, 8, 10, 16. Here in binary 0 and 1 only. Here 0 to 7 only in octal number system. In decimal number system, 0 to 9 only. If I am going to consider hexadecimal number system, 0 to 9 and A to F. Whereas A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15. Now is it clear for all of you? Next class you will come to know regarding how to convert a decimal number to binary number, or a decimal number to octal number, or a decimal number to hexadecimal number when you have the fractional part without having fractional part. That will explain you in the next class. Thank you for all of you.